Now we're going to get a lot of practice in with if statements and just different ways we can use if statements. So first up, let's just look at an if statement by itself. I'm going to write something really simple that just takes the absolute value of something. So what that means is, if you remember from math, when you have a positive number, the absolute value of that positive number is just itself. So if we had the absolute value of 2 is just equal to 2, and if we had the absolute value of -2, that's going to be 2 as well. The idea is, what is its distance from 0? And we don't care about the sign, just the distance from that number from 0. So it's a pretty easy concept. My number line isn't symmetric, but you get the idea. So it's a good way to just use an if statement. Let's create an integer, ask the user to enter a number, and then we'll display the absolute value. So if the number is less than 0, then it's a negative number. So we're just going to turn it into a positive number. I'm going to say the number is equal to the opposite of itself. So again, if we take a negative number like -2 and we put another negative outside of it, that's going to turn it into a positive 2. So that's what we're doing. We have a variable, so we have x, or whatever it is, equals -2. So if x is less than 0, x is equal to -x, so that's -2, which gives us +2. Otherwise, if it was greater than 0, nothing would have to be done. We don't care. Here we can output the absolute value is number. So since we modified number here, we can just reuse it here. If it was positive, we didn't have to change anything. It just works as is. And I wrote that in the wrong file. So let's figure out what file I put that in. That's a common error. If you get undefined reference to main, you might be in the wrong file, because I opened up all of my projects ahead of time. So build and run, enter a number, -100, the absolute value is 100, 500, the absolute value is 500. So I wanted to also do another program with if statements that doesn't have that absolute value stuff, just in case you're not as familiar with it. This one's just going to give an overdraft warning, so let's do float, price, and balance. So the price is going to be the price of an item, and this is going to be the user's account balance, so how much money they have in their account. What is your account balance? How much does the item cost? And then here we can remove from balance whatever the price was. So we're taking the balance and subtracting the price from it to set the new balance. And we can say if the balance is less than 0, overdraft. So then we can say your balance is now. So if they end up going over, basically if their price is more than what they have in their account, oh, it just crashed. That was cool. So if the price of the item is more than what they have in their account, then it will complain. So if we have 50 bucks and we're spending 25, it's fine. We have 25 left. But if we have 50 bucks and we're spending $100, it says that there's an overdraft and the balance is now -50. So that is how a basic if statement works on its own. So let's go to the if-else statements now. I have some other example code. You'll be able to access all of this on the repository for the class, for CS200, my class. So that's just all under the example code folder, and there's a branching area, and then I'll save these new projects into there as well. Okay, so we're going to work with account balance again. We're going to modify this old version. This is in the new if-else account balance. And instead of just displaying the overdraft, what we're going to do is not let them overdraft. So if they want to buy something but don't have enough money, it'll just say like card denied or something like that. So before we do any sort of math on it, we can say if the price is greater than the balance, then user doesn't have enough money, else. So the else case would be whatever the opposite is. User does have enough money. We could also check if the user has enough money and have the else case do the other thing. So we'll write it both ways just so I can show you. So user doesn't have enough money, card declined, otherwise card accepted. So then at this point we can say balance is equal to balance minus the price and not change the balance if the card was declined. So we can run it, 50 bucks, buy something for 75. Oh, I am running the wrong program. Account balance, activate that one. $50, cost 75, card declined, still have $50. $50, buy something for $10, card accepted, now we have $40. So that would be if we're checking first if the user doesn't have enough money, then else the other case, the only other option is they do have money. Either they have enough money or they don't have enough money. If we want to check this the other way, if the price is less than or equal to the balance, this would be checking it to see user does have enough money. And the else case would be the user does not have enough money. So then we basically just take the same code in here but change which order they're in. So this is going to be, let me just label as way 1 and way 2. We don't want both of these in the program at the same time because it's going to like double subtract from the balance. But just to show that there are two different ways. Price greater than balance, that means not enough money. The flip side of that, the opposite, is going to be price is less than or equal to the balance. So in this case, if we had is $20 greater than $10, then that's true. Is, let's say, $10 greater than $10, that's not true. It has to be greater than or equal to. So the opposite of a greater than sign is going to be less than or equal to. So that's something you have to keep in mind. The opposite, let's say we'll have greater than, equal to, how can I maybe organize this a little better? Less than, equal to. So the opposite of this is going to be less than or equal to. The opposite of this is going to be less than. This is going to be greater than or equal to and greater than. So if 50 is not greater than 50, then it is less than or equal to 50. If 50 is greater than or equal to 50, then clearly 50 is not less than 50. I know that like verbally just writing it out and saying it doesn't make it as clear, but we can kind of see different examples. So 20 is not less than 10, 20 is not less than 20, 20 is less than 30. At the same time we can say 20, the opposite is true. 20 is greater than or equal to 10, 20 is greater than or equal to 20, but then this is false. 20 greater than or equal to 30, that's false, so no. Okay, so for this pizza builder program, we're going to let the user choose from different types of pizzas and then calculate the price of the pizza based on that. So we'll be using an if statement with some else if statements. So for example, let's just write the if statement first and we'll add in the variables we need afterwards, because sometimes it's not immediately clear what you need until you try to start writing that logic. So we need to know like if selection we don't have a variable for that yet. If selection is pizza 1, else if selection is pizza 2, else if selection is pizza 3, and so on. So we know we need to have some sort of variable for the user to choose. We also need to have some sort of information of what pizza 1, 2, and 3 is. So let's go ahead and display a menu. Let me try to think of some pizza types, maybe just cheese pizza. And we'll have a just a pepperoni pizza by its, like, nothing else there. Pineapple and Canadian bacon pizza. Number 4, let's say buffalo chicken pizza. Number 5, lots of veggies pizza. Number 6, let's see, vegan veggies pizza. So like maybe we'd remove the cheese or something. So we'll have 6 types of pizzas. So we'll end up having 6 options here. And I want the user to just enter the number that they select for their order, because that's just easier for us to check with. So we're going to have int pizza choice, which pizza, cn pizza choice. So now we have a variable to go in here. If pizza choice is 1 or 2 or 3 or 4 or 5 or 6, then that's fine. We can also put an else statement in case they enter 7, 8, 9, or even -10 or something like that. So for the else case, we would just say invalid pizza selection. But the rest of these will be valid. Okay, now the next thing we want to do is display how much their pizza is going to cost. So cost of pizza, and we don't know yet, and we don't have a variable for it, so we need to have some sort of variable for the price. Let's have float price, and we'll output price down here, but we don't know what the price is yet. We're going to set the price based on which kind of pizza we're making. So in here we can say cheese pizza. That's simple. We could hard code some prices. We'll do it in a couple different ways. Let's say price of a cheese pizza is $9. Price of a pepperoni pizza is $9.50. I'm just making up different prices. What do we have? Number 4. Let's just also say 10. Price is $9.25. Price is $9. So these are just some hard-coded prices for different types of pizza. So I can build it, we can choose a pizza, and then it'll tell us the cost. We can also make this a little bit more sophisticated, like let's put in some const. So for instance, let's say const topping, const float topping price, maybe 40 cents. Const float cheese price, I don't know, I'm just making up some numbers. So, and then const float base pizza price, let's just start everything at $9. So for cheese pizza, we could have the base pizza price plus the cheese price. For pepperoni pizza, we could have base pizza plus cheese plus 1 topping. Pineapple and Canadian bacon is going to have 2 toppings, so we could say topping plus topping. Or if we wanted to simplify that, we could put 2 times topping price, because we have 2 toppings. Buffalo chicken pizza, maybe that's only 1 topping, but maybe we have an extra sauce or something. So number 4, let's add a sauce price. So const float sauce price. That's not like a tomato sauce, so it's just an extra sauce price, like buffalo sauce. So we'll add that on. Lots of veggies pizza. Let's say that we got that and cheese, and let's have multiple toppings. Let's say you have to have at least like 5 toppings for a veggie pizza, right? And then for the vegan version, we're just going to subtract the cheese price. We're not going to have that part. So then we have different calculations for how each of these prices, pizza prices are calculated, and we can display it. I'm also just going to add a quick little end line here to separate things out a little bit. We can run. Which pizza? Let's get the lots of veggies pizza, $11.30. Now, here it doesn't display the 3-0. We'd have to add some extra logic in there, but we're going to skip that right now. We're not going to get into that. We're just looking at if statements. But you would have to use a set precision flag. Okay, so this will be in the example code repository as well. Let's look at doing some nested statements. So in this case, we're going to do a simple restaurant. I don't know if I spelled that right or not, but let's just also have a simple menu. Let's say hamburger, fries, beer, and soda. And then we can ask, what do you want to order? We need some sort of menu selection, so I'm going to put int menu choice and put that in here, menu choice. So I'm going to add some prices in here just for reference. I don't know how much beer usually costs because I don't drink beer or any of that stuff. We'll make soda cheaper. Okay, so we'll have a price. Now if the menu choice is 1, that's hamburger, going to set price to $10, else if menu choice is 2, that's fries, price is 5, else if menu choice is 3, that's beer. We're going to add some special logic in here. Else if menu choice is 4, that's soda, so price is 4. Okay, now for beer, what we have to do is we have to card the user, basically. So we can say int age and ask the user, what is your age? Have them enter their age. And we can have another if statement inside of our if statement. If age is greater than or equal to 21, otherwise. So if age is equal to or greater than 21, we can just set the price to 12. And otherwise, we can just say, you can't have any beer. And we'll just set the price to 0 because we're not really like looping through and adding a bunch of menu items. We only can select one at a time. So we'll output price, price. So this is not old enough, and we have a check in here. Now I'm going to show you a different way you could write this as well. So if I say beer and I say that I'm 50, which is not true, then it'll do that. And if I say I'm 10, also not true, then it'll say you can't have any beer. I could also write this with and logic operators, because when we have a nested if statement, we're basically saying this is true and this, or this is true and this. So another way we can write it would be to say else if menu choice is 3, and we'd have to ask them their age ahead of time, but age is greater than or equal to 21, else if menu choice is 3 and age is less than 21. So if we had to do it this way, we'd have to actually ask their age earlier, which wouldn't necessarily make sense for ordering burgers and all of that, but these are two different ways we could do it. We could say the price is 12 in this case, or you can't have any beer in this case. So that would be way 1, this would be way 2. So whatever looks cleaner, really, since it doesn't make sense to ask the user their age unless they're ordering a beer, there's not really a good reason to do it this way. So the better way would be, in this case, using that nested if statement and then only asking their age if they want to order a beer. Otherwise, like, you don't go somewhere and order a hamburger and then they're like, okay, what's your age, kid? And then you're like, 15? And then they're like, okay, you can have a burger. Like, that doesn't happen. So only asking age if they want beer. That would be an example of using nested if statements. Let's look at using the and, or, and not operators. So and is double ampersand, or is double pipe, and not is an exclamation point. So to start off with, let's ask the user what their grade was. We'll just use an integer. Enter your grade 0 to 100. So first, we'll check to see if the grade is valid. There's different ways we can do this. So we can say if grade is greater than or equal to 0, and grade is less than or equal to 100, then this is a valid grade. Or we can check to see if it's invalid. We could say if grade is less than 0, or grade is greater than 100, then it's an invalid grade range. So I'm going to draw this on a number line as well. Let me just see if I can kind of organize this so you can see both at the same time. So if we have a number line and we have 0 at minimum and 100 at maximum, and if we want to check if it's valid, let me see, then we want inclusive these values. Anything in here is valid. So that's greater than 0, greater than equal to 0, and less than equal to 100. That makes it a valid range. It will be invalid if it is less than 0, anything over here, or anything greater than 100. So less than 0 or greater than 100. So that is what we're checking for. We have and, or, I know those are, maybe I can just move these, move it up here. Invalid if less than 0 or greater than 100. Make sure you have your and or statements correct, because if you put this, a number cannot be both less than 0 and greater than 100 at the same time. So that would be saying it has to be both over here and over here at the same time. Likewise, if we had an or with this part, we would essentially be saying, let me draw another version of this because that'll make more sense. If grade is, let me do a lighter color. If grade is anything greater than 0, so everything this way, or less than 100, so everything this way, then basically every single number is valid. Make sure you have and when you only want it restricted to a specific range. And also, to show the not operator, we need to think about if we have A and B versus not A and B, what is that logically equivalent to? Likewise, if we have, let's say, C or D and not C or D, what is that logically equivalent to? I will say these are logical opposites. They're covering different things. Notice that less than 0 is using less than 0, and then the and range is using greater than or equal to 0. So whenever you logically negate a greater than equal to sign, you'll have a less than sign. And when you negate an and statement, it's going to give you an or statement. So in this case, not A and B is logically equivalent to not A or not B. And here, not C or D is logically equivalent to not C and not D. So if we're saying the grade is greater than or equal to 0 and less than or equal to 100 to be valid, Well, we could have 0, we could have 10, we could have 90, we could have 100. Those are all valid. If we had something that caused it to be false, if this statement right here was false, basically if we had an else case that triggered, then that means the grade is going to be something like maybe -1 or 200 or something like that. So when we negate this, we have grade is less than 0 or grade is greater than 100. So there are 3 different little chunks here to this logic problem. We have the relation right here. This is the first part. This is the and this is the second part. And all 3 of these get negated on their own. So if we have something that causes this original statement to be false, like a -1, it means either the grade ended up being less than 0 or the grade ended up being greater than 100. So in this case, that means grade is less than 0 or grade is greater than 100. Down here, if we have the else case for this, then we have a valid range. So let's write that out. A grade is invalid if it's less than 0 or if the grade is greater than 100. So invalid ones are going to be something like -2, -5, 200, 1000. So those cause this to evaluate to true. The grade is negative or it's greater than 100. So that would be true. If we wanted to negate it, what if this was false, like in here, if this ended up evaluating to false, what that means is the grade ended up being somewhere between greater than or equal to 0 and less than or equal to 100. So if we had 90, this would be false. If we had 25, this would be false. So again, to negate it, we have 1, 2, 3 segments. So grade ended up being greater than or equal to 0, and grade was less than or equal to 100. So when this is false, we get the valid grade. So down here, this means grade was greater than or equal to 0, and grade was less than or equal to 100 at the same time. This might not yet be super clear to you. It's good to review logic operators and get some practice with it, and you'll also see this in a class like discrete structures or discrete math. So it does take some getting used to. But at least for now, I tried to kind of step through how that logic works. So keep in mind that the opposite of and is or. The opposite of or is and. And then we have our opposites of a less than is greater than or equal to. There's just different logical rules, and we've gone through a little bit of it here, but we'll have more practice elsewhere. So another thing that's kind of tricky when you're first starting off with if statements is knowing when to use an if versus an if else if, or using 2 different if statements. When do you use two different if statements? Well, if you're checking on 2 different things, but that might not be super obvious starting out. So here's an example where we're going to ask the user for their checking account balance, and we're going to ask them for their savings account balance, and then we're going to do 2 separate checks. We're going to see if the checking account is overdrawn. If it's less than 0, we'll say checking is overdrawn. And then we're going to do a check for the savings account. Savings account is less than 0. Here, the savings account is overdrawn. And these are checking on 2 separate things, so they are separate if statements. If you did this, and both of these checking accounts, both the checking and the savings account was overdrawn, it would only display the checking one. But we need it separate so you can see both of those separately. So let's say we have -50 and -100. It'll tell me checking is overdrawn and savings is overdrawn. I'm going to add a little ends line in here. Or if I had $25 here, but -50 here, it will show just savings is overdrawn. Or -50 and 25, checking is overdrawn. Or if they're both fine, it's not really going to display anything. So if if I have negative in both of these accounts, it'll display that both are overdrawn. But if I had else if here, it'll only display checking is overdrawn because it goes to the first true statement and ignores all the rest. So in this case, we want to look at both of these values. So these are two separate if statements, logically. We're checking the checking account, we're checking the savings account. I shouldn't phrase it that way. We're looking at the checking account, we're looking at the savings account. Now we're going to look at a switch statement. So anything you can write as an if A equals this or that, you can write as a switch statement. It's not going to work for if A is less than 100 or stuff like that. It's only to see, is this equal to this thing or this thing or this thing? So here we'll ask user enter number 1, enter number 2, enter a math operation such as plus, minus, multiply, divide, and then we can check to see what kind of math operation we have. Also, I'm going to declare a result variable. So we could write this as an if statement. Let's just do that first. If operation is a plus sign, since this is a character and they enter in just the plus symbol, we're going to put the plus sign inside of single quotes. That's how you write a character. Else if operation is subtraction, else if operation is multiplication, else if operation is division. And then we could do like a check to see if it's divide by 0 or not. So if they hit plus, we'll say the result is A plus B. If they did negative, we'll do A minus B, A times B, and then in here, we would do A divided by B, but we should also do a check to see if B is 0. We'll just say cannot divide by 0, and maybe set the result to 0. We don't really have a good way to set it to something like this is not valid. Otherwise, it's fine to do the division, and at the very, very end, we'll say result and display the result. So based on that, we can say, let's say 5 and 7 will add is 12, 12 and 6 subtract, and so on. And we can do 10 divided by 0, and it will complain, and it'll tell us 0, which is not the solution, but we needed to have something in there just so it doesn't display just garbage. I guess you could display garbage if you wanted to. So we're going to change this to a switch statement. I'll just keep this here. Down here we have using switch statement. So I can comment all of this out, and we will do a switch statement looking at the operation variable. So we're going to write a series of cases that relate to the operation. So case plus means operation was the plus sign, and then we're going to have break at the end of this statement. Case subtraction, case multiplication, case division. Now we need to have the break statement here, otherwise it will continue flowing through each of these cases. We will look at this in another example afterwards, because sometimes you might want that to happen, but most of the time you might not, so we're just keeping it here. We need to have the break at the end of our case statement. So in here we'll have the same result equals A plus B, result equals A minus B, result equals A times B, and we can still do an if statement in here. I can copy this and have this if statement just checking to see if you're dividing by 0, and it's fine. You can have more code inside of there. I like to kind of indent these just because I think it makes it easier to read, and then we can run this and do the same operations again. Now, I will say if we have a integer and we're dividing by an integer, it's going to give us an integer back. 10 divided by 3 is not going to be an even 3. If we had 10 divided by 3, 3 goes into 10 3 times, that gives us a 9. Subtract, that gives us a remainder of 1. So we'd have basically 3 and 1/3. We are losing that remainder here. We're losing the remainder because these are all integers. When we divide two integers, C++ is going to give us an integer back. I could change these to floats. Let's do float 10 divided by 3, and that'll give me 3.3333, which a third is equivalent to 0.33333 repeating. So if you're doing specifically division, like if we had integers, these would all be fine because an integer plus an integer or minus an integer or multiplied by an integer is always going to be an integer. That does not hold true for division. So if you want to do division, make sure you're working with floats. Okay. Finally, we're going to look at using a switch statement with a fall through. So for instance, let's say we're going to ask the user to adopt a pet, and let's say cat adoption is, I don't know, cats are usually pretty cheap. Dog adoption, I haven't adopted a dog. We've had a dog growing up. I don't know how much we paid for him, but I've only adopted cats. So I know dogs tend to be more expensive. Why can't I type with my number pad? There we go. We'll just do that. So we're going to instead, we're going to say you can type in C for cat, D for dog. What else we got? Let's say you can get a bird at this place. I don't know if birds are more expensive or not. We're just going to put them at $40. I'm sorry if you're a bird lover. I like birds, but I only have cats. Okay, so we're going to say char choice and ask the user for their choice. Adopt which. So the problem with this is the user could enter a lowercase b or an uppercase b. And we want to be able to make both of those okay. Now we could get around it by saying choice is equal to upper choice and then only check for capital B and C and D, and that would be valid. But we're going to examine using a switch statement with a fall through. So we're going to do a switch on choice, case B, break, case C, break, case D, break, and we can have a default. And default doesn't need a break, so we can say if they didn't choose B, C, or D, invalid choice. Okay, let me also create a price. Price is equal to 40. Price is equal to 50. Price is equal to 100. So price. So I haven't done anything with fall through yet. I want to just show that it's not going to work with, well, let's say these are uppercase because these are uppercase. So if I ran and typed a lowercase b, it's going to say invalid choice. So what we want to do is also check for if it's lowercase. So I could say case lowercase b, case lowercase c, case lowercase d. So since I don't have a break here, like that, it's going to look at, oh, we got case capital B? Okay, keep going. And then it'll ignore that this is case lowercase b. It'll just kind of keep going, do whatever code comes next until it hits the break, and then the break will cause it to leave that switch statement. So I can do lowercase b, except I didn't put the price down here. lowercase b or uppercase b, and both of those work. Where did it go? C. Okay. If we were doing this with if statements, we could say if choice is lowercase b or choice is uppercase b, we could set it that way. And again, you could also say choice is to upper choice, and then only have to check for choice is equal to uppercase b in that case. So there are different ways you can handle this, but if you're working with like letting the user enter a letter as an input, you do need to consider that they could do uppercase or lowercase, and you'll have to kind of adjust for that. Now I will say with your switch statements, you can use it with floats, you can use it with chars, characters, you can use it with integers, but you can't use it with strings, because strings are technically a class that was written by somebody else. A class is an object with functions and variables in it, and can't be used with a switch in C++. So it has to be just these really basic data types: floats, ints, chars, booleans, doubles, those sorts of things. So you can get to the example code by being on the course webpage, and there should be a link to the repository on GitLab. That will take you here, and you can look at the example code, and those are under branching. You can view these from the web, or you can download them to your computer. So if you click on that, you can see it here. If you want to download all of the code, it's going to be all of the files for this, which will include the lab specifications and such. You can click on this button to download, or if there's one particular piece of code you want to download, you can go here and click on this download button, and that will download just that file.